Hello, colleagues. Today we will have a really long agenda. We together try to understand what is it like a patterns in enterprise architecture. What is it anti-patterns? This is like our main topic, and we will cover four most interesting right now in 2025. What's like common problems, fears, how we can fix this, etc., etc. And of course, everything, as you're gonna mention, will be useful for you, so you can check our site and check this presentation. A lot of links already here. Yeah, so and recording will be available. That's why I hope tomorrow, yeah, you will double check and we'll try to use this information, this data within your like a job. So let's start. Let's start with understanding what is it like a patterns and anti-patterns. And first of all, let's focus on what is it architecture. In IT, in architectural world, we have ISO standards 24010 with name Systems and Software Engineering Architecture Description. And this ISO standards pretty good for us in IT industry to cover term what is it architecture. Based on this standard, architecture is a fundamental concept or properties of the system, and this system, of course, live in some environment, yeah, and includes different elements, relationship within this element, and last point, really important, sometimes architects, solution architects, enterprise architect forgot about that you as an architect should create a principle of design, so how architecture should be created and how this architecture can be changed, adjustment within some time. That's why I believe on the bottom you can see architecture. It's about four main terms: properties of the system, some environment, elements and relationship and relation within these elements, and of course last but not least, principles of its design and evolution. Next topic, it's about levels or types of architecture. So yeah, we will focus on enterprise, but not only on enterprise level. We can say when we talk about architecture, and let's like identify from bottom to up, from application architecture or architectures to enterprise. So on bottom level, we have application architecture. Usually, when we discuss about application architecture, it means mobile application or front-end application, like a web application written on JavaScript, for example, or our backend. So this is some part of components or group of components that we should focus on. Usually for this part of components, again, backend or mobile or front-end, we use our technical leads, technical experts, sometimes senior developers, of course, can contribute middle developers or juniors, but it's about one single application or some category, like again, backend, front-end, mobile, etc., etc. When we move on to next level, to like a product level, so how, for example, our front-end will collaborate together with backend part on, again, as an overall product, together with mobile and backend, etc., etc. Here we can say about solution architecture, and usually we use some solution architect who responsible for overall product. Usually these persons are stack agnostic. It doesn't matter what technologies already in place. A common idea of solution architecture to provide a clear architectural blueprint how all components work together, of course, to achieve all business goals. And next level, like a top level of architecture, it's about enterprise. The again, we have in our IT industry a lot of definitions, but personally, I like from TOGAF, one of most popular enterprise architectural framework. Next definition. This is like a highest level, typically, of description of organization, and typically covers all missions and functions organizations, plus of course, product or products, so multiple products. That's why when we say about enterprise architecture, it's not only about like a product, or products. It's about overall organization. So this is like an organizational structure, how the should be drive this organizational structure, maybe work with vendors, work with different teams, different products, integrations, etc., etc. What else we have? We have a really interesting term, BDAT. Again, this is from different enterprise architectural frameworks. This is acronym, and we can say that enterprise architecture includes 4 different aspects: business or layers, business layer, data layer, application layer, and technology layer. So business layer is about business strategy, money, again, organizational structure, etc., etc., and of course, how we drive identification of all business objectives and all business goals. Data layer, again, I believe it's pretty easy. This is about data management, about our storages, security part of data, data ingestion, integrations, etc., etc. Application layer, I believe this is really related to solution architecture and application architecture. And if you work as developer, of course, you work on application layer, some part, and using data layer. And last in this term, technology. Technology layer is about our infrastructure. This is about DevOps culture or DevSecOps culture, SRE culture. So it's everything on what in the past we use like a hardware. So long story short, here enterprise architecture, it's about business, it's about data and everything around data. It's about our applications, backend, frontend, mobile, etc. And technology, it's about infrastructure. And that's why right now we know what is it like an enterprise architecture and what should be on enterprise architecture stuff. So enterprise architect should cover all of this part. That's why when you try to apply to position enterprise architect, you should know not only some technology part, but of course data part should be here and business part should be here. And what we have in our world to use when we say, let's create enterprise architecture. Of course, we have different architectural methods and frameworks. So top to bottom, on bottom to up approach. So how we should create architecture, component-based thinking, DDD, I believe you know about that. Different architectural guidelines like a Microsoft architecture guide or architectural framework, or different architectural methods from different architectural schools like from Software Engineers Institute, Carnegie Mellon, attribute-driven design, or big, pretty new architectural school, EOS. If you try to research each of these method or framework, you of course can simplify somehow, again, after couple of iteration, that okay, each of this method or framework you can split to 6 steps. So first of all, again, it doesn't matter Is it like application architecture or solution architecture or enterprise architecture? So first of all, you as architect or maybe architect within your team should collect as much as possible information from different stakeholders using the different elicitation methods. Sometimes it's workshops, sometimes quiz, etc., etc. And then you, as an architect, or again, architect from your team, should analyze this information. And a lot of information really comes from different stakeholders or from IT industry, and you should sit and categorize somehow this information and identify significant requirements or architecturally significant requirements that should be split to different categories. Functional requirements, of course, we should go to business analysts to product managers to support here. But again, this is responsibility of architect too. Constraints, like our limits, concerns from again different stakeholders or from your personal experience. Then quality attribute scenarios or NFRs, non-functional requirements. And of course, you should identify risks and assumptions related to this product or products. After that, on step number 3, you should choose different architectural methods, tools, design principles, choose architectural tactics, how you will create design. Again, it doesn't matter. Application, mobile, backend, solution, overall like a solution, or enterprise. In parallel, of course, like a step number 4 or 5, it will take, of course, time, and usually it's most important for us in architectural world steps. I mean, creation different architectural views, diagrams, tables, documents, and of course, you should choose or sometimes say like generate, create decisions. My personal rule here, and usually we use like a term choose architecture because first of all you should identify alternatives in technologies, again in some decision, and create clear trade-off analysis. And after that, of course, you should create some roadmap how our development team, delivery team, or delivery teams, multiple teams, will implement your architecture. Again, it doesn't matter on level, enterprise or solution or application. You should be aware about that. So, and again, this is like an iterative process. And within this 6 steps, you can use different design concepts. You can use reference architectures. You can use different architectural tactics or some deployment patterns. So how your infrastructure will look like. Of course, different ISO standards, RFCs, requests for comments, will support you. Of course, different tools, development framework like Angular, .NET, Spring, whatever. Different already existing platforms and technology will support you. But really important part, and colleagues, I believe you know from your university, this is like a big field, and for usage, this is like architectural patterns and styles. And we have in our IT world a lot of architectural styles and patterns. On business level, on data level, on application level, I believe most of you, if you developer, of course, knows microservices, etc., monolithic architecture, or service-oriented or micro front-end. So application level or application patterns and styles most interesting for you because you as a developer, again, if you developer, work on this level. And of course, technology architecture. Again, this is about infrastructure. Here we have long list of our architectural patterns and styles. And this list, yeah, of course, you can focus on this list that's I added to my slide, but we have a really long long list of books or catalogs where you can find architectural patterns and styles. Sometimes, yeah, you can use some books. For example, personally, I usually recommend books from Software Engineering Institute, pretty great books from Neil Ford, Mark Richards, like Fundamentals, Software Architecture and Architecture, the Hard Parts. Of course, classical books for patterns of enterprise application architecture and enterprise integration patterns. Pretty great list of architectural styles and patterns from Microsoft in their Azure Architectural Center. And colleagues, please check Microservice IO and Architura patterns, because here you will find pretty great list of architectural patterns that, of course, it would be great to use in your product, projects, platforms, etc., etc. And let's back to our common topic. What is it anti-pattern? Personally, me, I like Sam from Neil Ford. He wrote pretty great book, Building Evolutionary Architectures, together with great persons, yeah, co-writers. And these persons identified, including Neil Ford, of course, identified term, what is it anti-pattern? So, what is it anti-pattern? Practically, initially, it's like a good idea, was a good idea, but when we implement this and on production, potentially it was mistake, and better alternatives or solution or technologies already exist. At the same time, we have second term like a pitfall. Pitfall looks like again good idea, but we implement with using not the best practice. That's why sometimes, yeah, when you start creation some project, yeah, you or your colleagues propose to use some anti-pattern, or again propose some good idea without any analysis or trade-offs, and after couple of iterations, yeah, or a couple of releases, you can say, oh my god, why we choose this? I believe we should remove some technology or remove some methods that we choose for right now. I mean, using, for example, shared database, or start with monolith or whatever. Again, this is like on the example that sometimes it's happened. Today, yeah, we have pretty great books and catalogs, so where we can find these anti-patterns and how we can like identify this is like some problems in our project when we have delivery initiation, and how be assured that, yeah, this is anti-pattern. On more than 25 years ago, yeah, we we started identify this with this like a great book, anti-patterns, yeah, where you can find 41 anti-patterns and mini anti-patterns within three categories: architecture, development, and of course project management. And within this like period of time, more than 25 years, of course, our industry migrated from monolithic to microservices, from big databases to distributed systems or distributed databases. And we implemented, unfortunately, a lot of anti-patterns. That's why for right now, not only like this book, it's pretty mature and really relevant, but we have another books and catalogs where you can find pretty good list of anti-patterns. Again, the same book that I already mentioned, Building Evolutionary Architectures, and Microservice Anti-Patterns and Pitfalls, from Mark Richards. At the same time, of course, as you remember, BDAT, within enterprise architecture, we have this term, and last one is about technology level or infrastructure. Of course, DevOps anti-patterns we have. And as you can see, we have a lot. For example, on the right side of this slide, you can see from AWS Well Architecture framework, AWS already defined pretty clear DevOps guidance, and already identified 116 anti-patterns. And of course, colleagues, I will recommend to check all of this. Maybe start with, again, AWS. It doesn't matter what cloud right now you in progress with using, Azure or IBM or GCP. AWS collected pretty great list of anti-patterns. For today, our agenda, I will explain 4 of them most interesting, and we identify like a situation, what common problems within this, like a 4 common interesting anti-patterns, like a design by committee, bad data virus, Swiss Army knife, and operational overtooling. 4 of them usually you can potentially can find in your project or in your previous project, by the way, because it's pretty classical that we have for right now, because again, 10 years ago, we migrated from monolithic architecture to services, not only microservices, to service architecture. That's why we right now have a lot of anti-patterns in our existing products. But let's identify what is it and how we can identify, do we have a problem, and how we can identify, will we have a problem, and will we have these anti-patterns within our project. First of them, business anti-pattern, or within business layer, or within enterprise, design by committee. What is it? Usually we have different situations or different problems. What problems we have? First of all, we start a project or product rapidly, quickly. Let's go to code, to coding, to testing, to delivery, etc., without some architecture. Or some architect, one person created architecture, maybe collected somewhere in Confluence, but this person did not present to us. Or again, architectural document created, stored somewhere, but not understandable. What our development team will do with this? Of course, we try to re-architect, or again, to create a bicycle, during our development. We sometimes find some architectural decisions somewhere in Confluence. Okay, good, but it's really complex. Again, we have no this architect right now. We focus on right now in our estimation, agile, blah, blah, blah. So design really complicated, and we try to do a lot of refactorings, and sometimes we use a lot of research tasks, like spikes. This title usually our delivery manager use, and of course cost for maintenance and extensibility really high. Yeah, sometimes it's like a low level of switching from one technology to another because again, architecture was not presented. Yeah, or again, some complex, not understandable. Second classical situation, not clear architectural decision making process. So many people want to influence design. Again, we have a lot of spikes, like this name of tasks in our backlog, a lot of technical depth. Again, long meetings with some conflicts. One person say, "No, we should use Cassandra as a main storage." No, 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 MongoDB. Then after 1 hour of clarification, delivery manager say, "Okay, guys, do you have some suggestion or decision?" "No, we need couple of meetings." "Yes," or rescheduling, etc., etc. And on final stage, we have slow delivery. We increase time to market. Our business objectives potentially not achieved because release deadline not achieve was not achieved, or again not all features already implemented, or again pure quality because not a clear decision making process. And third one, classical situation, not consistent vision. Okay, how we measure our success? We have a good architecture. Okay, super. We have a good technologies. Yeah, our team pretty good, implements pretty mature again architectural decisions, but how we can measure our success? What like metrics we can use? And again, before release, yeah, for example, during user acceptance testing, before 1 month, or again 2 weeks before release, we try to identify metrics, KPIs. Okay, what is it, a good product or with good quality or not a good. We try to implement a lot of observability tools to collect these metrics, and potentially again sometimes happen a release not relevant because we disable some features because we don't know quality of this feature. Yeah, business doesn't meet some KPIs, etc., etc. And this is like a common problems. And within like a next release, we try to sit together, yeah, and fix these problems. Yeah, so right now we have some design by a lot of people. Yeah, so architecture drives somehow. Yeah, and we try to identify some dedicated architect, or maybe some small team dedicated architects. For example, backend architect, mobile architect, data architect, maybe cloud architect. Okay, so it can be like not only one person. It can be like a couple of persons and work together. But again, here potentially we can have some anti-patterns on enterprise level. Sometimes, again, it happens, architect play golf. This is like a classical anti-pattern that architect, we identify this role only for couple of months, yeah, or allocate this architect for a couple of months. This person creates some architectural design, and after a couple of months say, "Yes, guys, goodbye." Yeah, and without any like a clear vision how team proceed with driving architecture, yeah, back to his or her previous like stuff. That's why this is like a pretty not a good situation when architect we have no access during development to architect. Second classical pitfall or anti-pattern that we can have if we allocate this person, ivory tower architect. So architect is like a shadow person. Yeah, so yes, this person creates some design work maybe within Jira tickets. Yeah, but we have no access to this person. And this person cannot present his or her architecture. This is like a really classical problem. And of course we should fix somehow this situation. When we have architects only for couple of months and then architects say like goodbye, or we have no access to this architect. Architect generates only some documents, but not explain what is it and how it should be implemented. In this case, we should create some committee, or again our name of this anti-pattern designed by committee, but this is not the name of problem. This is like a name how we should fix this. So what we should do, of course we can allocate this architect and we should evaluate do we have these problems or not? I mean, this like architect play golf or ivory tower architect. So we know that it's potential problem, so try to mitigate. So what we should do, we should create some community. Let's use this word, community or committee, technical design committee. Potentially, what persons or roles we can add to this community? Of course, architect. Of course, if we have a couple of teams, squads, we can allocate to this community technical leads or team leads. We need, of course, QA person. It can be QA lead or again, more mature QA, quality assurance engineer, who can drive quality assurance practice. Of course, DevOps person we need within this committee, delivery lead, someone who can drive and who can provide vision how it should be delivered. And of course, someone from product from product team who can support us in vision regarding priorities. So this like a committee, or community, what on first meeting, what we should do. First of all, we should choose architectural frameworks and methods, and I already presented to you, so it's great that you specify or choose a couple of them. For example, you can sit together, and specify like rules of game, so how we will drive our architecture. For example, using stay ADD together with trade-off and together with Microsoft architectural guide, or maybe some additional methods, or again, we will use like a TOGAF, fully implementation or some partial implementation of TOGAF within our project or product. Second step, we should identify clear architectural decision process. For example, for decision process for some product increment for PI, or again, architectural decision making process for some small tasks. But all of us within this like a program, project, whatever, or organization, all of us should know how architecture should drive. First of all, analysis of initial requirements, identification of ISRs, architecturally significant requirements, using architectural principles, trade-offs, creation of ADRs, and of course, implementation plan. Third step that we should do, we should choose architectural viewpoints and tools. So how we will create final deliverables of architectural group or technical design committee or this community. You should like specify limit of tool set for this team, or again for your organization. Because, for example, for creation of diagrams, sometimes it happened that someone used Lucidchart, someone used some AI tool, someone used C4 model, someone UMR, etc., etc. So you should specify some limit of tool set and that you should use and your team should use. What you should specify? First of all, you should specify viewpoints. What viewpoints your team will use for creation some architectural diagrams. For example, UML and C4 model. These two, usually I personally recommend to use because again, this is pretty mature. After that, you should specify limit of tools for creation these diagrams. For example, plant UML, for architecture as a code approach, and for example, draw IO for creation some visualization. And of course, you should specify some list of main diagrams that we should use in our, for example, Confluence or in our documentation artifactor. And last point, you should specify really single one format, how all decisions will looks like. This format we already have in IT industry, in architectural world. This is name ADR. This is acronym, Architectural Decision Record. What is it, Architectural Decision Record? This is like a mindset or culture. Yeah, I believe culture is more, but a term that's already provided, I believe, more than 10 years ago. And already use it a lot. And this is a best practice within software and hardware architecture, how each your decision should look like. Yeah, so this is about format. So you should sit together within your team, architects, technical leads, QAs, DevOps, and say, guys, if we need to choose technology, if we need to, for example, specify how backend will communicate with front end, or some integration or data management, or again, our CI/CD process or branching strategy, or on organizational level, some relationship between different delivery departments, etc., we should use for these decisions one single format. And we should specify this format. For example, each ADR should include ID, title, status, like a proposed, in progress, already approved or rejected. So why rejected? Yeah, some related ADR, some related decision group of this ADR. For example, you can choose for groups, for a list of groups, this like a term, acronym BDAT, I mean business decisions, then technological decisions, application decision, or some infrastructural decision. Yeah, so and data decision. Then of course you should specify for each your decision some context or problem statement. Then again, why I mentioned that in architecture we usually say that we not create architecture, we choose architecture. Because as you can see, point, one of last point in ADR should be considered options. So again, it doesn't matter, is it about delivery, for example, methods choosing, you should first of all identify some alternatives like Kanban, Scrum, Safe, whatever, or Waterfall. Then create a clear vision regarding trade-off analysis. So and of course specify like attributes for this trade-off analysis based on your context, and then identify best of the best for us in our case for right now, and identify this decision. That's why again, this is like a main 4 steps that you should identify as rules of game, within one or maybe couple of meetings within this group. But your product team members, each of them should know how you should drive architecture on different levels of enterprise, plus of course how architecture and all decisions should looks like, within one single format. And okay, we specify this like a stuff for design committee. This design committee focus on business objectives, functional requirements, not functional requirements, mitigate the risks, identify assumptions, use assumptions, again, identify some metrics and how we measure these metrics. This is about fitness functions. But of course, we proceed drive our delivery. So this team, of course, should specify on the like a start of their like a life architectural methods, choose tool set, identify some principles. After that, of course, you should use some regular sync meetings. Usually it can be weekly meeting for 1 hour to see what architectural decisions should be created within some roadmap. I mean, delivery roadmap. Of course, what architectural views our team should create, etc., etc. And last but not least, it's about, of course, support our delivery team or delivery teams. I mean, our developers, QAs, DevSecOps, engineers, data engineers, and all other engineers. And the design committee, of course, can be responsible and contribute to some proof of concept, creation of prototypes, of course, maybe implementation some complex features. But again, most important point that this design committee should support overall delivery and should support delivery teams, not only create and generate some content, I mean decisions, but explain delivery teams how it should be implemented. If you have already, for example, design committee, but you can identify maybe some problems. So this slide, it's about how you can identify or measure or measurable metrics to support you identify we have right now problems with our architectural design, and let's implement this design by committee. First point, of course, you can identify how many meetings we have. For example, again, as I already mentioned, if your meetings about choosing technologies and your meetings about like a grooming or some identification of scope, choosing technology, etc., it's pretty long. That's why, okay, you right now identify that you have this anti-pattern. So how you can mitigate this? Of course, try to maybe move some ad hoc meetings to some regular meetings to identify what meetings we have for right now, how many people we have in these meetings, and try to limit this design by committee, I mean limits of people. Of course, if you identify some design consistency, inconsistency, so your current architecture, it's not looks like our current target architecture, and of course you should fix this. If you find some lot of technical depths, for example, code complexity metrics or a lot of defects per number of code, thousands of lines of code, you can say, okay, we should maybe drive our architecture with different way. Or again, you can identify and come to your delivery manager and ask what current problem with our timeline, I mean actual versus planned timeline. So maybe we have a problem, why we have this problem, or maybe a cost for our infrastructure pretty high. Our team already did a lot of spikes, like researches. So how we can do this, and fix these problems. Here again, next steps, what you should do. First of all, allocate architect. It can be with title architect, or it can be person more mature engineer or maybe not only engineer who can combine this role, I mean architect, and who can drive and to be this like a lead of technical or architectural committee. After that, create this like a community, yeah, with minimum final decision makers. Because if you will have a lot of decision makers, again, you will have this like anti-pattern. Third step, to identify or unify framework for analysis your requirements. I mean, identification these like architectural significant requirements, how you drive this. So what elicitation methods you should use, or workshops or quiz or some meetings, whatever. Yeah, and then of course on step number 4, you should identify fitness functions. It's pretty new term in architecture, but it's pretty understandable. This is like your rules, how you should measure and what you should measure, some KPIs on the final stage after implementation. Step number 5, it's about specification, some architectural principles. It's some general rules or axioms that your architectural decisions will follow. For example, cloud agnostic, or again, use as much as possible cloud services, or security on all levels. It's like a classical architectural principles, or most interesting like architectural first, that first of all, before coding for each like a feature, you should create some architectural decision, and only after that coding. Again, this is like a classical examples of step number 5, the specification of architectural principles. But in any case, you should have this table somewhere in your documentation. Step number 6, unification of your decisions. I mean, using one single format for each of your decision. I mean, using architectural decision records. And then after number 6, when you identify like a rules of game for driving your enterprise architecture, you should promote this. You should explain for each team member that, guys, for right now, we use this approach to drive architecture, and of course, you can contribute. For example, create some architectural decision record with status proposed, and it's look like a request for comment. And each week, yeah, on weekly basis, this design committee sit together, see from developers, from QAs, from DevOps, from data engineers, AI engineers, this like a proposed ADRs, for example, for fix something or improve something, or migrate from one technology to another technology. And this committee, of course, review this like a proposition from team, and again, at the same time, team knows how can contribute to architecture. And then some part of these ADRs, of course, can be rejected because I know not for a objective for right now for implementation, but it should be clear explanation. And again, this is iterative process to review this process. I mean, driving architecture and prioritization, feedbacks, and collect feedbacks from different stakeholders. Second bad bad data virus anti-pattern from data layer. Here we have pretty interesting situation. Each year we can identify that our data globally really grows. Yeah, and for example, using this report, we can say that till end of this year, we will have a lot of data within like all our clouds, on premise, etc., etc. At the same time, Gartner already identified pretty interesting term like a dark data. So what is it? Dark data is it information that's already collected process and store somewhere, but not use it. And based on a report from company Veritas that already identified common three types of data, like business critical that use it, then root data or obsolete data, some legacy data, and some dark data. So as you can see, within, if we back to this slide, so 175 zettabytes, let's imagine that we together generate within this year, and only 15% of this data will be useful for business. At the same time, 52% of data, this is like a dark data. Why we use this data, we don't know. This is some data that we collected, we maybe transform somehow, and but we don't know why we do it. Again, this is like from this report, but I believe this is more realistic, like numbers rather than not realistic. So why we have this and what is it bad data views? Let's imagine we have some not understandable data in our data source, like a golden source, and we have some current product or some current project. Okay, then business come to us and say, guys, we should increase our availability. And what we should do? Of course, we create a replica. Yeah, read-write replica. And right now, our bad data or dark data, not only in golden source or golden records, we have this in our replica. Okay, super. Then again, business product managers come to us and say, guys, we should create some SaaS product. Let's use some data ingestion tool, and we need to collect all our organizational data in one data lake and provide this data to SaaS. In our case, this like a bad data or dark data right now in our data lake. Okay. So and again, we increase our like data, and so we increase our like bad data or dark data within not only golden record. Right now, it's in data lake. Okay. Then again, business come to us and say, guys, we need like a high available data lake. Okay, super. Right now, as you can see, bad data on a lot of data lakes. Okay, we collected this, and so, for example, 1-2 years ago, of course, each business tried to implement AI and try to, of course, create vector embeddings, try to use somehow already collected data and what we have in our LLMs or in our organizational vector embeddings. Yeah, this like a red box, yeah, with bad data. And right now, this dark data or bad data everywhere. Yeah, and why we have the situation? Because fear of deleting data. And why we have this? On golden source, for example, 5 years ago, let's imagine this like a project or product. Yeah, we collected everything. Yes, super. But right now in 2025, we have this like bad data everywhere. Why? Because 5 years ago we did not delete this data or archive some data, and right now it's really big problem. At the same time, our data grows, yeah, globally. And why we have this problem? Because bad data views. So how we can identify, do we have this anti-pattern or not? First of all, you should, of course, assess your data. Yeah, so how data, some database storage, or again, some really like rows in your database, you use it. So you should check data access frequency, data read-write ratio, user query, access logs, etc., etc. Second point, or again, it can be on parallel, each of these steps, you should evaluate data storages. Yeah, so volume of data, utilization rates, age of some data, etc., etc. At the same time, you should understand your data quality and some data governance and compliance points or metrics like a data ratio metrics, compliance audit results, of course, your performance and efficiency metrics like cache hit miss ratio, classical one, and maybe again your bad data within your infrastructure, like your observability tools, monitorings, logins, tools already generate a lot of data, and you have no any idea why we should do this. Why we should keep data from logs within like 5 years. Again, for example, So in this case, what you should do, you can use these metrics, measurable metrics, to identify do you have the bad data or not. But to mitigate this, so how you can fix this, it's pretty clear. This is like a main 4 steps. First of all, you should conduct data audit or assessment, because audit is pretty strict term. Let's use like a assessment. After that, you should implement some data classification approach. If you back to this, so this is like a explanation potentially how you can like categorize your data: application data, infrastructure data, maybe some data for business, I mean for some visualization. Okay, you can specify these categories, but again, you should create this like a list, of your storages or where already stored a lot of data, to identify is it bad or not. Then, of course, you should create some policies. You should create or develop data retention policy, archiving policy, deletion policy. Because again, to mitigate this problem that you collect bad data, and right now bad data everywhere, and try to, of course, use automatization to manage this process. Maybe automatization or deleting something, maybe archiving something, etc., etc. This is really a common problem. And for example, if your product already on production more than 10 years, and right now you try to implement, for example, AI or whatever, of course, you can identify, guys, we have a problem because cost of data or data storages, because of data, because of cost of infrastructure, etc., etc. This is classical anti-pattern, but we have a clear list of metrics and clear list of steps how we can fix this. Next one, application level, or and we will discuss about Swiss Army knife. This is like a classical anti-pattern from development world. So you know what is it if you again work as a developer. When you try to create complex class or put all methods to one interface, or again add to one bundle, plugin, or model, a lot of functionality. Again, this is like a classical anti-pattern in software development. But let's see what we have in distributed systems. So here, let's back to 20 years ago, when we used service-oriented architecture, when we used like a monolithic architecture, and of course, as you remember, like using Oracle, it's like classical technology, with a lot of stored triggers, stored procedures, views, etc., etc. And here we have the same anti-pattern, yeah, Swiss Army knife, and a lot of models connect to one shared really huge database, and our core team really cry every like a day, a week, months, because should support this like triggers, procedures, and views. But within time, yeah, in 2010s, we had a classical case. Let's migrate from monolithic architecture from this huge, oh my god, database, yeah, to some services architecture. Not only microservices or like a service-oriented architecture, service-based architecture, but let's move from monolithic architectural style. What we do, what we did, yeah. So first of all, yeah, okay, we keep our shared database, yeah. We try to split our monolith to macro services, then migrate to microservices, yeah, using iterative process. And so we, of course, split our database using DDD approach or whatever. Yeah. And what we have some services, yeah, and of course we try to use some event-driven design, yeah, to add a messaging system. Again, it doesn't matter, RabbitMQ, Kafka, or some cloud native messaging system, but we should use event-driven design because we have, of course, we had a lot of direct connection between services, I mean backend services, yeah, and we try to mitigate a problem with availability, performance, and try to use event-driven design. Of course, we start with classical dilemma orchestration versus choreography, but again, we know how it can be mitigated using Saga, for example, for transactions, using different tools. Yeah, I mean Kafka again, or RabbitMQ or whatever, but it's not a problem. What we have for right now? Right now, we try to decouple our business logic, yeah, from services. Then we try to add some, again, potentially, sometimes it happens. We try to put some responsibilities because we try to remove this direct connection between services to messaging system. So right now, we try to add not only messagings, we try to add security functionality to messaging system, maybe some failover cluster here, maybe some protocol switchings, then load balancing, some management, oh my god, business logic here. Of course, we should add some routing, maybe transformation of data. And right now, our core team, if you remember like problems with 20 years ago with database, try to do and fix problems within messaging system. And here we have anti-pattern in distributed system on application level of enterprise that Swiss Army knife right now, not in code base, yeah, not in like a class or model or bundle. We have problem that's messaging system has a lot of responsibilities. Yeah, and our core team try to fix right now everything and spend a lot of time not implement something as a business features in some services, but try to implement orchestration, choreography, transformation, whatever within some messaging system. And what problems we have with this? First of all, overloaded messaging system. Then of potentially performance bottlenecks. Difficulty in making changes. For example, one developers who had knowledge with this like a messaging system created this functionality, but we moved these developers to another project or projects, or again these developers left a company. Yeah, that's why current developers try to like create some changes, implement some changes. Yeah, of course, problems with debugging, monitoring, again some maybe hidden business logic within within these like messaging systems, and of course problems with message context. That's why again a lot of like symptoms we have, and in distributed systems it's really problem. So how we can measure this like a matrix, measurable metrics to support identify is it problem for right now or not? First of all, what you should do, you should come to DevOps engineers and you, of course, should check together some utilization. So is it problem for it now in messaging system? I mean, CPU usage, memory usage, throughput, latency, etc., etc. You should identify numbers of message types and transformation, and of course, some numbers of services dependent to this like some specific message types. Of course, you should identify some incidents, maybe again Kafka or RabbitMQ or some cloud native service, sometimes broken, and you should identify like main parameters like mean time to detect of some incident or mean time to recover or some other again metrics. Of course, monitoring, debugging will support you here. And you should check, of course, together with your architect, together with your development team, business logic in this like a messaging layer. So what percentage of business logic already implemented? And again, as you remember, 20 years ago, we used stored procedures and triggers, and so on the 2010s years, we migrated this like stored procedures and triggers to services, I mean, to backend services. Potentially, so what you should do if you identify that for right now your messaging systems, it's really huge. First of all, you try to simplify your messaging system. Review your complex rules, scripts, some complex logic that already implemented, maybe within Camunda. Again, this is like a classical tool that you can identify this problem. Or again, maybe it's not a problem, but and this is not an anti-pattern because this matrix you provide and this matrix pretty good. But again, sometimes it's problem. Second step, you should simplify message types or decrease number of message types that already use it within your system. Then you should establish clear messaging protocols and contracts. For example, again, limit of this because sometimes we use multiple messaging protocols. Then you should decentralize some business logic to microservices. Of course, adopt some smart endpoints and dump pipes strategy. I mean, decision making within services rather than move responsibility again to messaging systems. And of course, you should use together with DevOps engineers the pretty robust observability and monitoring strategy for your messaging flow. I mean, distributed tracing. And the last 2 points, it's about implementation DDD principles, some domain events, to identify is it good for right now strategy for communication between services, and last but not least point, of course, conduct regular architectural reviews and refactoring. Potentially, who can support us here? Our design committee. That we already implemented. Again, if we back to our first anti-pattern, but this anti-pattern with name like fix. So design committee potentially can support us here, to do these steps to mitigate problems with this anti-pattern. And last, again, pretty standard classical anti-pattern that usually we have in our project programs, operational overtooling. More than 15 years ago, we started implementation and using DevOps culture. or SRE culture. And this SRE or DevOps culture supports a lot of teams. Yeah. And as you can see, we have different categories that our DevOps engineers or DevSecOps engineers should do. For example, of course, control version, infrastructure, the code implementation, CI/CD process, supporting visualization, observability, logging, quality control, etc., etc. And sometimes our team implement a lot. Implement a lot of uh, uh, tools. But why usually we have a lot of tools? Because of some fear of manual intervention. So we usually implement DevOps practice. Right now we have AI ops practice, IT ops practice in the past we had, and our world for right now try to move to no ops. So without manual intervention, because people can broke something. Of course, we have benefits, yeah, with this no ops approach. For example, maximize development time, no manual intervention, full cloud capacity, etc., etc. At the same time, we have challenges because when you try to implement no ops approach, yeah, you increase your workload. Potentially, you decrease security. Again, potentially. And when you try to fix something, you, of course, again, back to manual intervention. Because if something broken, yeah, of course, no ops can support, but this is like a pitfall that we have no ops mirage. When some incidents on production happen, of course, our monitoring logging tools or alerting tools can provide us this information. But again, you should ping some SRE engineer for manual intervention. That's why maintainability costs increase, incidents increase, etc., etc. That's why you should use some balance between no operations and manual intervention. And again, why we have over tooling? Because sometimes we have resume-driven development. Developers, DevOps come to us and say, guys, we have pretty long list of tools. Let's use this. I didn't have a chance to use some tools, and let's try to use something. Yeah, and what you should do as an architect, and again, you know what is this architectural committee? You should first of all to specify some ADR, architectural decision record, and not implement everything. You should implement only tools that fix some problems or cover some context. Yeah, we have this table, pretty great. We have this like a list of tools from cloud native landscape company, but again, you should limit tool set, and sometimes you can see that you have some duplication tools that use for one reason and for one responsibility. What we have if we have like over tooling? First of all, classical anti-pattern that usually we use, focus on tools but not people. Yeah, so DevOps culture usually focus on implementation and support people rather than only to add something to your ecosystem and support something. So DevOps, again, as a culture, try to fix a people problem. Of course, business cover business objectives, but you should focus on not only tools but people and how we can fix problems of people. Our developers QAs, data engineers, of course, with focus on business objectives. And DevOps, this is like a second classical anti-pattern. DevOps is only automation. This is like a wrong, approach. And automatization sometimes, as I already mentioned, you should like a balance manual intervention, and of course some part of should be moved for automatization. Why? Because on right side, as you can see, and as you remember, data, anti-pattern, potentially our data can be gross, and in this case, if we use no ops or no operational approach and try to collect everything, I mean, monitoring, logging, and this with this approach, we collect a lot of data. And this data really grows. We collect data from pipelines, from log files, customer information, geolocation, emails, old documents, etc., etc. Because again, no operations. That's why we potentially will have a problem with the bad data virus. We know what is it, and how you can measure, or what metrics you can use to identify. Do you have right now operational overtooling on or not? First of all, you should evaluate of all tools, that already use it. What metrics you can use? Obsolete tool count, tool usage frequency, and some percentage of tools feature that's already actively use it. And for example, if some tool, really complex tool, already in place, and only one feature use it, maybe it makes sense to migrate from these complex tools. Or again, maybe you should use this tool more features rather than only one, because again, this is like a cost for infrastructure. Second categories of metrics, measurable metrics that you should use, of course, integration time and effort. If some tool you can see that for implementation will take, for example, 1 month, again, let's imagine, or maybe more, maybe some alternatives can be and already exist within IT industry. Again, this is about trade-off analysis. You know how you should implement this. I mean, within ADR implementation, within your architecture, and of course, try to identify alternatives and choose best of the best based on context. And last category for metrics, it's about cost. Of course, you should check tool licensing cost, training and support cost, and resource utilization. So how we use this, and how we can train. Is it easy to train our team? For using this tool. And last, in our action points, so what we should do? First of all, conduct tool audit or assessment and create a software bill of material. This document where you identify or specify a list of tools that or platforms or licenses. Again, it doesn't matter. Is it on your a cloud for right now, or is some third party tool that already in place? Of course, you should implement some governance for tool management. Maybe you will create some DevOps tooling committee. Or maybe it will be responsibility of this your technical design committee to check tools and review existing ones and managing integration. Of course, you should define pretty clear tool adoption strategy with a clear list of criteria for adoption, some new tools. Because again, in IT industry, we have each year we have something new, some tool right now legacy. That's why potentially maybe you will migrate from one. It makes sense to migrate from one tool to another tool. But what you should do, you should create clear strategy for tool adoption. For example, POC first of all, or prototype. Then, for example, add this tool to one part of product, or type of products, and then launch to overall your organization, etc. Of course, you should standardize or minimize a number of tool sets for each category. Try to balance automatization and manual intervention, and continuously again monitor and measure tools based on this KPIs. If you back to this slide, and improve your documentation, knowledge sharing, and of course train and onboard new team members effectively, because again new tools potentially will come to us, to our project products, and each team member should know how it can be implemented and can be used. What next? After this, my speech, what you should do? First of all, your next step to identify what is it anti-patterns and pitfalls, and identify and resource some catalogs, because again we have a pretty great book, we have a couple of resources, and at the same time, second step, of course, identify, and right now regarding 4 anti-patterns, what metrics and observability strategy you can use to identify, do you have some anti-pattern or within your project product or not. And again, you should specify a clear action plan, how you should mitigate everything or fix these problems.